All right, today we're working on the 4.3 notes, and 4.3 is geometric sequences. Previously, we've done arithmetic sequences, and that's when you keep adding the same number over and over. That same number we call the common difference. Today, in geometric sequences, we're going to be multiplying by the same number. So, to just fill out the top here, a reminder, a sequence is an ordered list or pattern of numbers, letters, objects, etc. But there's an order to it. It's not just any list. 1 through 8, these are all sequences. They are not necessarily one type of sequence. So if you notice here in number 1, it actually is an arithmetic sequence because we keep adding 4. So the next one would be 19. And then 23. Number two, I'm going to circle. That's one of the new ones from today. Because to go from 3 to 6 to 12 to 24, you are multiplying by 2. So for this one, we're going to say R, your common ratio is 2. Number three, you got to notice a couple things. First of all, the numbers are getting bigger. You keep multiplying by, they're basically doubling, but the signs are changing. So that means you're multiplying by a negative. Negative, positive, negative, positive. So your rate this time, common ratio, would be negative 2. So that'll give us positive 16 and then negative 32. At this point, you can stop the video. You could pause it. Or you can just mute me for a second while we fill out 4 through 8 if you don't want to listen. I feel like you can probably figure them out. 4, you don't really multiply by anything in particular. Here to here, we add 2, we add 4, we add 6. So the pattern would continue. We're going to add 8 and then 10. I have no name for that pattern. It just is what it is. We add 2 more each time. Number 5. 5 gets a circle. Oh, 3 should have got a circle too. 3 and 5 and 6 while I have my pen out. On number 5, you are quickly decreasing. 1024 to 512 to 256. In fact, you're taking half. So even though we're dividing, we're going to say you're multiplying by a half. So half of 256 is 128. Half of that is 64. Number 6, going 3 to 1, 1/3, 1/9. So again, we're getting smaller. And to get 3 to 1, that's a third. A third is a third of 1. You have to multiply by 1 over 3. So continue that pattern. 1 over 27. Again, multiply the top by 1, the bottom by 3. 1 over 81. So again, you could look at it as dividing by 3, but for this section, we're not talking division. You're going to multiply by the reciprocal instead. So R equals 1/3 for number 6. Number 7, it's a funny little pattern. The numerators are 2, 4, 6, 8. So we'll go 10 and 12. And then the denominators 3, 5, 7, 9, 11, 13. The numbers in number 8 should look familiar. 1 squared, 2 squared, 3 squared, 4 squared. So 25 and 36. Hopefully you remember those are perfect squares. Okay, so as I mentioned already, a sequence with a common ratio, you might see it as a common multiple between consecutive terms is called geometric. The next term is found by multiplying the same number to the previous term. Of course, we have an explicit and recursive. They're kind of sort of similar as the arithmetic version of them. We're still using function notation, so f of n equals, you're going to write the first term times whatever you keep multiplying by, your r. And again, we're going to have n minus 1, but in arithmetic sequences, it's repeated addition, so you can multiply by n minus 1. But this is repeated multiplication, which is shown in life with exponents. So you have to plug in the first term and your common ratio. And then that's it, you leave it like that. So unlike the arithmetic sequence, you don't have to simplify. It just, that's it. So to find it, very simple here. Find the first term, find the common ratio or multiple. You may see either words used, and I may use either words. And substitute values into the formula, which we just wrote above. The nth term, you do the first term, times your common ratio to the n minus 1. Again, n is the term number.